All right, so the first problem on this worksheet, well, the first side of the worksheet is solving equations. So what we should be doing on this whole first side, because they're equations, we want to clear the fractions. So figure out the common denominator, clear fractions. Now on the back side of this worksheet, for the inequalities, we have to keep the fractions because we need to know how the numerator and denominator work together to divide out to positives or negatives. So first thing I'm going to do is factor a little bit. So I'm noticing that I've got an x times x minus 1 for the first denominator plus 8 over x equals, right here you've got 6 over 2, factor 2 out, times x minus 1. And you are allowed to, and you should, reduce 6 over 2. So it's actually just equals 3 over x minus 1. And then I want to, putting extra equal signs in here, I want to multiply to clear out the fractions. The denominator that will clear out every denominator is x times x minus 1. That's the same as setting up the LCD if you were to get a common denominator. If we multiply by that, we'll wipe out all the fractions. So the first term just becomes 8. On the second term, the x's cancel, so you'll have 8 times x minus 1. X minus 1's cancel, you'll have equals 3x. And now it's just a matter of solving. Eight x equals 3x. However you want to do this. Maybe you solved it back there. I subtracted 3x over. If 5x equals 0, what does x equal? 0. But remember, for rational equations, we need to check for extraneous solutions, which means go back, and it probably would have been good for me to make a note of what the excluded values from the domain are. Because we have a denominator of x, x can't equal 0, and because of the x minus 1, x can't equal 1. So because my only solution is one of the excluded values, because that's extraneous, there's actually no solution to this problem. You can confirm all of these graphically. If we were to graph the left side of the equation in y1, the right side in y2, we should see that the only points of intersection they have, or, well, I should say this, the only thing, they don't intersect, and either we'll see that there's a hole at x minus 1, or more likely it'd be a vertical asymptote. I said x equals 1, at x equals 0. All right, next one, nothing to simplify. I can get right down to multiplying both sides by the LCD, which is x minus 1, x plus 1. So that leaves us with 3 times x plus 1 plus 1 times x minus 1. Don't really have to write the 1 there. Equals 4 times, I'm just going to, these are conjugates, they're easy to FOIL together. I'm going to make that x squared minus 1 because I know that's my next step anyway. So 3x plus 3 plus x minus 1 equals 4x squared minus 4. I see that I have an x squared, and I like to keep mine positive, so I'm going to move everything to the right side of the equation, but I can clean this up a little bit first. Over here I have 4x plus 2. I'm also noticing I can divide everything by 2, but I'll do that after I get it equal to 0. So 4x squared minus 4x, and then if I subtract 2 from negative 4, I get minus 6. Again, with equations, you're allowed to divide both sides of an equation by a number. You just would never divide by x. So this makes it 2x squared minus 2x minus 3 equals 0. And I always like to give a couple of tries with factoring, especially if the first term there is easy to split up. I've got these prime numbers to work with. So let's see. If I do 3 and then 1, I'll get 6 and 1. That's not going to give me 2. If I put 3 here, 1 here, I'll get 2 and 3. That's not going to give me 2. So this one, I guess, doesn't factor. I still think it's always worth a try, which means I'm going to switch over to quadratic formula. So x equals positive 2 plus or minus square root of 2 squared is 4 minus 4 times 2 times negative 3 all over 2 times 2. This is going to be 4 plus, let's see, 8 times 3. 4 plus 24 is 2 plus or minus radical 28, which will simplify in a minute, all over 4. Radical 28 is 2 radical 7. So simplifying this, I've got a 2, 2 and a 4, or you can say like you're multiplying 2 over 4, or you're reducing 2 over 4 and 2 over 4. I'm just dividing everything by 2. So I get 1 plus or minus the square root of 7 all over 2. Okay. Next problem, we've got some factoring to look at in the denominators again. So I can take a 2 out of this one. We've got a difference of squares here. We can take a 2 out of this one. And here's another one where before you dive right into clearing out the fractions, just pay attention anytime you take out a GCF. I can reduce here and just make my numbers a bit smaller. So 10 over 2. So really I have 5 over x plus 4 minus 7x plus 8 over x plus 4x minus 4. No reducing to do there. Oh, I didn't see this negative sign at first. So equals, let's put this negative up here with 8. That's just kind of easier to think of. So negative 8 divided by 4 is, or divided by 2 is negative 4 over x minus 4. I like to move negatives to the numerator if they're just single numbers like that, just so I don't forget about it or so I don't like miss it. It's easy to overlook that. All right, so then the next step is to multiply by the least common denominator, which is x plus 4x minus 4. To both sides of the equation, and that gives us 5 times x minus 4. This negative sign, you have to be careful with this. So the x plus 4x minus 4 cancel each other out. It's minus the entire numerator, 7x plus 8. So put parentheses around that or distribute the negative through right away. That's the most common mistake when there's subtraction, that people will only apply it to the first term and not everything after that. And then on the other side of the equals, the x minus 4's cancel, so we have a negative 4 times x plus 4. And then let's distribute and start solving this. So we have 5x minus 20 minus 7x minus 8 equals negative 4x minus 16. Negative 2x minus 28 equals negative 4x minus 16. I'm going to add 4x to the left side, and I'm going to add 28 to the right side. So it's negative 16 plus 28, or just 28 minus 16, is 12. X equals 6. When you get an answer, check your extraneous solutions. I didn't mention that for the previous one, because if you're doing quadratic formula, those are not the original denominators that we had to worry about. This was like x can't equal plus or minus 1, which is not that value. Here, look at the factored form. X can't equal plus or minus 4, so 6 is okay. Okay, next one, let's factor what we have. This trinomial factors into x minus 5, x minus 3. Oh, and then here's one of those backwards factors. So let me rewrite this problem so it doesn't get too messy. So I'm just going to copy down some of this. Okay, we had this in our notes. 1 over 3 minus x. 3 minus x is not a different factor from x minus 3. And you don't want to go multiplying both sides by x minus 5, x minus 3, 3 minus x, because that's not the least common denominator. You've introduced an extra factor that's going to make the problem a lot harder. So remember, you're allowed to factor out a negative, which I'm going to put up with the 1 up there. And factoring out a negative would make the x positive and the positive 3 negative. So factoring out a negative turns it around into the standard form order that we're used to seeing. And then we can multiply by the LCD at this point, which is just x minus 5, x minus 3. And so that wipes out the entire denominator for the first term, 7x plus 3, plus 3x, that'll get multiplied by x minus 3, equals negative 1 times x minus 5. So distributing here, we have 7x plus 3x squared minus 9x equals negative x plus 5. So 3x squared. Now we're going to have 7x minus 9x is negative 2x. And then I'm going to add this x to the left side. So what did I say? Negative 2x plus x is negative x. 3 minus 5 is minus 2. And now I got the thing equal to 0. You don't have to skip steps like that if you want to simplify the left side first. That's smart to do as well. I'm seeing if this factors. It feels like it kind of wants to, right? If I make this minus 1 and this plus 2, that gives me negative 3x plus 2x, yes, and they'll multiply to negative 2, yes. So this one factored, and that makes my solutions negative 2/3, and positive 1. And then I go back and check and say, well, my only restrictions were that x couldn't equal 3 or 5, so both of these solutions check out for this problem. Okay, this one, let's see, we have x minus 3x plus 2, which are the exact two denominators we have. So again, on this one, we're just going to be careful when we multiply by the LCD, x minus 3x plus 2. Be careful with this negative sign here in the middle. All right, so we get x times x plus 2 minus, the whole denominator cancels out. So again, minus parentheses 7x minus 6. Sorry, I got distracted. I was just thinking this sounded familiar. I wanted to make sure it wasn't the same problem. Anyway, minus 7x minus 6 equals 2 times x minus 3. X squared plus 2x minus 7x plus 6 equals 2x minus 6. So x squared minus 5x plus 6 equals 2x minus 6. Subtract 2x, x squared minus 7x. Be careful here, you're going to be adding 6, so the 6's do not cancel. Add 6, you get plus 12 equals 0. That factors nicely. X minus 4, x minus 3. Solutions are 4 and 3, but always go back and check. X can't equal 3 or negative 2, so 3 is out. That's extraneous. So x equals 4 is the only solution for this problem. All right, last equation to solve. Then we switch to inequalities on the next page. Now here we do have 3 different factors for our denominators, and there's nothing we can do to make them be the same. So we do need to multiply by 3 factors this time: x plus 2, x minus 2, and x plus 1. And because each denominator only has one factor, it means you're going to have 2 factors being multiplied in. Like the x plus 2's cancel, so the first term is 1 times x minus 2 times x plus 1. And then the x minus 2's cancel, so the next one's going to be plus 1 times x plus 2, x plus 1. And on the other side of the equal sign, it's going to be 3 times the x plus 1's cancel, so x plus 2, x minus 2. So just a lot of careful setup here. We have to multiply all this out. So x squared minus x minus 2 plus x squared plus 3x plus 2 equals, now this is going to be, I don't want to write this on a separate line, 3 times x squared minus 4, so 3x squared minus 12. And I want to clean up the left side first because it'll be too much for my brain to keep track of. So 2x squared. Negative x plus 3x is plus 2x. Negative 2 plus 2 cancels. So that's not so bad. I would like my x squared to be positive, so I'm moving everything to the right side. So subtract 2x, subtract 2x squared, so you get x squared. Subtract 2x, minus 2x, minus 12 is already there. That seems like it ought to factor. Maybe not though, let's see. 6 and 2, 4 and 3, it does not factor. So, seems like it ought to, but it doesn't. So, x equals opposite of b, positive 2, plus or minus, square root of, negative 2 squared is 4, minus 4 times 1 times negative 12, all over 2 times 1. What's underneath the square root there? 4 plus 48. 4 plus 48 is 52. You'll see I often write down these little, there's no shame in writing down small amounts of work and things like that. I don't know. Somewhere along the way, it seems like people try to reduce the amount of work, but my brain cannot keep track of all that. So please just write stuff down, because the number of silly little computational errors really that could be avoided if you just write stuff down is kind of surprising. I'm sure 52 divides by 4. It goes into 5 once. It's 4 times 13. So this is actually 2 plus or minus 2 radical 13 all over 2. So x equals 1 plus or minus radical 13. Remember, the radical answer is the exact answer. If you were to type this into a calculator and give me the decimal version, that's now the approximation. Now, on the back of this worksheet, we're switching gears because these are inequalities. So remember, we wrote this at the top of the page. You need to keep the fraction, and you should have number lines for every single one of these problems. So the first thing I do is find the critical numbers. And I like to label which critical numbers are x-intercepts, which ones came from the top. -4 and 1. This one's factored out nicely for me. And which ones would be vertical asymptotes, or values that came from the denominator. Because remember, when you're plotting on a number line, you plot open circles for vertical asymptotes and then closed or open for x-intercepts, depending on if the inequality is equal to 0 or not. So this first problem, even though it's nicely factored for us, so we didn't have a lot of work to do to find this part, we have a lot of sections we're going to have to test. So first thing is, put these numbers correctly in order on the number line. So -4 gets a closed circle. It's an x-intercept. It's where we're equal to 0. -3 would be next. Open circle, because it came from a value, makes us divide by 0. And then we would hit +1, closed. And then we would hit 2, open. So we have 1, 2, 3, 4, 5 intervals between all of these numbers that we need to test to see, because I can't just sketch this graph off the top of my head. So we need to see, when I plug in a number in each section, does this overall fraction come out positive or negative? The nice thing about being in factored form is you don't have to always get the exact numerical answer. You're just looking at signs. So if I plug in -5 plus 4, I get -1 squared. -5 minus 1, -6. -5 plus 3 is -2. -5 minus 2 is -7. What's happening on the top? You're getting a positive times a negative. So an overall negative on top. The bottom, a negative times a negative is a positive. So when I divide this fraction out, if I actually get the numerical value, it's going to be a negative overall. So this entire section to the left of -4 will give us negative values. If we were graphing this, the graph is below the x-axis to the left of -4. Something between -4 and -3 is just -3.5. I think in mixed numbers or decimal forms like this, because again, I only care about signs. I don't care about the actual numerical value. Otherwise, if I had to find the number, I would make it -7/2. But in this case, it's just, yeah, negative 3.5 plus 4 squared, it doesn't matter what it is, squared is always positive. Negative 3.5 minus 1, negative 3.5 plus 3, negative 3.5 minus 2. Positive times a negative is negative. Negative times a negative is positive. So again, we're getting a negative overall. Okay, so these signs do not always alternate. We had in our notes examples, they might have all been like minus, plus, but having this multiplicity in here kind of messes things up. All right, let's test, 0, here we go. 0 is between negative 3 and 1, so 4 squared times negative 1 over 3 times negative 2. A positive times a negative is negative. A positive times a negative is negative. But a negative divided by a negative is positive. We're almost there. 1.5. Okay, well, squared is going to be positive. It doesn't matter what that is. 1.5 minus 1 is 0.5. 4.5. 1.5 minus 2, negative 0.5. A positive times a positive is a positive. A positive times a negative is a negative. And a positive divided by a negative is a negative. And last section. I'm going to plug in 3. That's to the right of 2. Again, something squared doesn't matter. It's positive. 3 minus 1 is 2. 3 plus 3 is 6. 3 minus 2 is 1. Positive over a positive is positive. Now, how much work do you have to show for me on a test? The amount of work that you show is up to you. You might, instead of writing these numbers, you might just be writing plus and minus signs. If I were grading this, I would be grading, I have to give the final answer still. I'd be grading the correct interval notation, looking for a number line that you didn't like multiply the denominator out. But yeah, the amount of work that you show for testing is just whatever you think you need. Now, what about the answer to this? We're looking for less than or equal to 0, so we're looking for negatives. This section, and this section. And be sure to simplify. Where am I going to put this answer? I'll put this answer next to the problem. So be sure to simplify. You don't want to say negative infinity to negative 4 to 3. Simplify that. That's continuous. So we want, get my arrow out of the way, negative infinity through negative 4 all the way up to negative 3, parentheses, and then square bracket 1 to 2, parentheses. That's our solution set for number 7. Now that problem was time consuming because we had 1, 2, 3, 4, 5 test intervals. The rest of these shouldn't be as long. I'm noticing that remember my first step should be get this compared to 0. So the first step should be subtracting 2 over to the left side. Oops. Remember, you are not allowed, your first step for an inequality will never be to multiply a denominator to the other side. You need to hold that fraction together. And I'm going to give myself some room so I'm not rewriting a million steps here. When I subtract 2, the next step will always be to set up a common denominator. So I'm just going to do that right now. So then the goal is to get this into one fraction. So it's all going to be over x plus 1. I've got x plus 6 minus 2x minus 2. You're distributing that negative 2 through. That's negative x plus 4 over x plus 1, less than 0. Remember, this is what you're testing into. So the critical numbers, there are only 2 of them. We have an x-intercept. When negative x plus 4 is equal to 0, x equals 4. And we have a vertical asymptote, x equals negative 1. Get those on a number line in the correct order. Negative 1 with an open circle. 4 is also with an open circle because the inequality is just less than. And then when we test numbers, we just have 3 sections to test into. So if I plug in negative 2, into negative x, you get 2 plus 4 over negative 2 plus 1. That's negative overall. Plug in 0, that's the best one. That's 4 over 1. Easy. Plug in 5 into negative x, you get negative 5 plus 4 over 5 plus 1. That's negative. And in this problem, it was less than 0, so we want the negative sections again. And so my solution set is negative infinity to negative 1, but not including, and positive 4, not including, out to infinity. Okay, same idea to begin with for number 9. So subtract 3 is your first step. And I'm going to, again, leave room for common denominator. So first step, get this compared to 0. Second step, set up your denominator and get into one fraction. So the common denominator is x plus 2. We have x plus 12 minus 3x minus 6 greater than or equal to 0. That's negative 2x plus 6 over x plus 2 is greater than or equal to 0. Critical numbers, which are just the numbers we put on our number line. The x-intercept, when negative 2x plus 6 equals 0, x equals 3. And the vertical asymptote, when x plus 2 equals 0, x is negative 2. Get your number line on there. 3 is filled in because it's the x-intercept, and this says greater than or equal to 0. Negative 2 is open because it came from the denominator, which would cause us to divide by 0. We're going to test negative 3 to begin with into your simplified function. When you put in negative 3, you get positive 6 plus 6 over negative 1. That's negative overall. Plug in 0, you get 6 over 2. That's positive. And plug in 4, and you get negative 8 plus 6 over 4 plus 2 is 6. That's negative 2 over 6, which is negative. In this problem, we want the greater than or equal to, we want the positive section. So my answer for number 9 is negative 2 to positive 3. All right. For number 10, it's tempting to want to cross multiply, but remember, you're not allowed to clear out the fractions. You can't get rid of denominators because the numerators and denominators act together to come up with the sign for the overall function. So subtract, I usually move things to the left side, so that's what I'm going to do here. So I've got my x's on the left. I'm looking for greater than 0. Now both fractions need an adjustment to get the common denominator. So it's going to be 4 is going to get multiplied by 2x plus 3. Negative 1 is going to get multiplied by x plus 5. And that's so that each fraction is over the common denominator, x plus 5 to x plus 3. Distribute. Simplify. 3x plus 7 over x plus 5 to x plus 3. So we have some fractions for our critical numbers, which is mildly annoying, but not a big deal. X equals negative 7/3. If it helps you, change that to a mixed number. 3 goes into 7 twice. Oops, too many commas here. Twice with remainder of 1, right? So negative 2 1/3. Gosh, there we go. And then for our vertical asymptote, x equals negative 5 and negative 3 over 2, which of course we know is negative 1.5. So for number line purposes, the mixed numbers are important so that you put them in the correct order. Negative 7/3. Now all of these are open because this is just greater than. Oops, I put it in the, see, I already put it in the wrong order. Furthest to the left is -5, and then -2 1/3, and then -3/2. Even though the critical numbers are fractions, it doesn't mean we have to use fractions to do our test intervals. So I'm going to pick -6 to the left of -5. We're going into this simplified function here. So that's -18 plus 7 over -1 times -12 plus 3. And again, the numbers I don't care too much about. It's just a negative on top, a positive on the bottom. That's negative overall. Something between -2 1/3 and -5, I would say is -3. It's -9 plus 7 over 2 times -6 plus 3. It's -2 on top, -6 on the bottom. That's going to divide out to a positive overall. Something between -2 1/3 and -1.5 would not be -1. Be careful with your number line here. It'd be -2. So if I plug in -2, I get -6 plus 7 over 3 times -4 plus 3. That's a positive over a negative, so you get negative. Finally, something bigger than -1.5 is 0. You get 7 on top, 5 times 3 on the bottom. We want the positive sections for this problem because it's greater than. So I'm going to write my answer up here by the problem. So my solution set is -5 to -7/3 and -3/2 to infinity. Okay. Now for this one, I put the x's on the right side. You can either move them to the left side, or it's okay to have the x's over here. I'm going to keep them on the right side just to show you what that looks like. So we are subtracting 6 to the right side, which means 6 is going to have to get multiplied by the common denominator so that we can get this together. So 5 minus 2x, distribute a -6 through. So -6 minus 18x, all over 1 plus 3x. 0 is greater than, let's see, so -20x, and then 5 minus 6 is -1, over 1 plus 3x. Okay, so what are the critical numbers? We have an x-intercept of if -20x minus 1 equals 0, x equals -1/20th. And then the other one is subtract 1 divided by 3, -1/3. On a number line, where do those fall? So get my number line out here. -1/3 is a bigger value than -1/20th. So -1/20th is closer to 0, which we'll just say is like over here. Testing in numbers, I would pick like -1 is to the far left. So if I plug in -1, I get 20 minus 1 over 1 minus 3. Positive over negative is negative overall. What's something between -1/3 and -1/20th? So pick any denominator between 3 and 20. So I'm just going to say -1/4. That's a bit smaller than -1/3, and it's bigger than -1/20th. Plug in -1/4 times -20, you get +5 minus 1 over 1 plus, 1 minus 3/4. That's a positive over a positive. And then 0 is to the right of -1/20th, so -1 over 1. These should both have been plotted with open circles. Now here's where I have to be careful. My x's are on the right side, so compared to 0, x is the smaller item, right? Remember back in grade school, you learned something about like the alligator eats the bigger number. So that was really just to help you. If the smaller numbers on the right side. So I am looking for negatives, even though that's reading 0 is greater than something, x is the smaller thing. If that messes with your brain, then please move the x's to the left side rather than the right side, and you will come up with the same number set. You'll come up with the same solution set, but you'll have opposite signs, but you'll be looking for positives that way. Anyway, my solution set is negative infinity to negative 1/3, negative 1/20 to infinity. And our final problem here, same thing as problem number 10. I cannot cross multiply or clear out denominators, so I am simply going to subtract and leave a bit of room for setting up common denominators. I'm going to subtract 3 over x plus 2. This is greater than or equal to 0. And I know I need to set up common denominators by multiplying each fraction by the opposite denominator. So I just wanted to not have to write everything more than once. So this whole thing is going to be over x minus 6, x plus 2. We're going to get 5x plus 10 minus 3x plus 18. That's 2x plus 28. Right? Here it matters which one's an x-intercept and which one's not because of the greater than or equal to. So the x-intercept is when x equals negative 14. That's when 2x plus 28 is equal to 0. The undefined values would be x equals 6 and negative 2. Get these on a number line, so it'd be negative 14, negative 2, 6. Closed, open, open. I'm going to test negative 15. That gives me negative 30 plus 28 over negative 21 times negative 13. Do not bother with the numbers here. That's a negative on top. That multiplies to a positive. That's negative overall when you divide. I'm going to use negative 3 for something between negative 2 and negative 14. Negative 6 plus 28 is positive. Negative 3 minus 6 is negative. Negative 3 plus 2 is negative. Positive divided by a positive is positive. So this is what I was saying before. You could even just show me this tiny amount of work. It's just for you. Plug in 0, you get 28 over negative 6 times 2. That's positive over a negative. If you plug in 7, and this is one where maybe you don't show work, when you plug in 7, you're getting a positive, a positive, a positive. That's easy to say. Everything's positive. The ones I write down are usually when negatives are involved. So final solution set for this one is including negative 14 to negative 2, not including 6 to infinity. All right, if you have questions on this worksheet, please come see me in office hours or ask during class.